Welcome back, children. I am back here to explain AAA criterion of similarity of two triangles from triangle chapter. Before actually we prove this theorem, there are certain requirements that we must know. We will explain about that, and then we will prove this theorem AAA criterion of similarity of two triangles. Let me read out the statement. From the statement we are going to extract few words. We will first know the meaning of those words, and then we will prove this AAA criterion of similarity of two triangles. We also know the meaning of what is AAA, everything. Let me read out the theorem now. Statement of this particular theorem: if in two triangles, if in how many triangles? Two triangles. If in two triangles corresponding angles are equal, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion. Once again, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar, The condition given to us is, if these two triangles ABC and DEF, equiangular triangle, if they have equal angles, if their corresponding angles are equal, then their corresponding sides divide in the equal ratio, or corresponding sides are in the same ratio, divides in the equal ratio or in the same ratio. Then if they are in the same ratio, these two triangles are similar. So this is what we are going to prove now. Before we prove, we should know what are corresponding angles. Because in the statement, so the word has come corresponding angles. And one more word is there, that is corresponding sides. Then similar triangle. Similar triangles. These three words meaning, let's know now. Consider this ABC and DEF triangle, in which, see properly, angle A is equals to 50 degree. Just an assumption to understand what is corresponding angles. Angle A is equals to 50 degree, and angle E is also equals to angle E is 50 degree. Since angle A and angle E have the same degree, the value of angle A and angle E are same, these two angles are called corresponding angles. Now observe, angle B is 60 degree and angle F of other triangle DF is 60 degree. Angle B is equals to angle F. Therefore, angle B and angle F are called corresponding angles. Next, what is left out? Angle C. Angle C of ABC is 70 degree, and angle D of DF triangle is 70 degree. So angle C and angle D are equal, and thus angle C and angle D are corresponding angles. So understood, children? Corresponding angles means they should have equal value. Angle A and angle E has equal values, therefore they are called corresponding angles. Angle B and angle F, value is same, therefore angle B and F are called corresponding angles. Angle C and angle D, the value is same, and thus these two angles are corresponding angles. Now What are corresponding sides? The sides which are opposite to equal angles. For example, angle A here, opposite to that angle BC is formed. Sorry, side BC is formed. BC. And 50 here, angle A is 50, angle E is 50. Opposite to that, which side is there? DF. This BC and DF are corresponding sides. How BC and DF have become corresponding sides? Because they are the sides opposite to equal angles. You cannot take DE as corresponding side with the BC because here 50 and here 60. Opposite to 60, DE is there. So we should not consider. Opposite to 50, opposite to 50. In both the triangles, which side comes? That side becomes corresponding side. Here, opposite to 50, angle 50, BC is there. Opposite to angle 50 here, DF is there. Therefore, BC and DF are corresponding sides. Next, you see that opposite to 60. Here, opposite to 60. Opposite to 60, we have AC, and opposite to 60 in DF triangle, we have DE. Therefore, AC and DE are considered as corresponding sides of the two triangles. Next, you know that opposite to 70, AB in ABC triangle, opposite to 70 in DF triangle, EF side is there. Therefore, AB and EF are corresponding sides. Did you understand, children? So, this is very important to prove this AAA criterion of similarity of two triangles. Corresponding angles, you should know not only for the theorems, for theorem based problems, these things are highly important. You should know the meaning of what are corresponding angles and what are corresponding sides. Corresponding sides are nothing but the sides opposite to equal angles. Opposite to equal angles. 50 opposite BC, here 50 opposite DF. Therefore, they are corresponding sides. But both should be equiangular. Both the triangles should be equiangular. Corresponding sides we can take only when the two triangles are equiangular triangle. Got it, children? Now you can know what are corresponding angles and what are corresponding sides. Now we will see what are similar triangles. Very important, similar triangles, because in various theorems, next, this similar triangles concept is very important. Two triangles are similar. Similar means what? Having same shape. That's all. In general meaning, similar means having same shape. But in geometric, in this way, in a geometric meaning, if you say that, if you consider two triangles, then two triangles are said to be similar if their corresponding angles are equal. If two triangles are equiangular. If two triangles are equiangular. The two triangles are equiangular triangle, then they are called similar triangles. Not only this condition, one more condition should be satisfied, that the corresponding sides divide in the same ratio. The corresponding sides divide in the same ratio. What is the corresponding sides? You know that here. What is the corresponding sides? BC and DF are the corresponding sides. So BC divided by DF should be equal to AC divided by DE. That should be equals to AB by EF. If these two conditions are satisfied, then the two triangles can be called as similar triangle. Understand? It's very easy. When you can call the two triangles as a similar triangle, the first condition should be their corresponding angles should be equal. If the corresponding angles are equal, then they are called equiangular triangle. The first condition is the two triangles should be equiangular triangle. The second condition is corresponding sides should divide in the same ratio. For example, what the value you get when you divide the corresponding sides? For example, BC and DF are the corresponding sides. If you divide, what value you get? For example, if you get some K, some constant value. Then if you divide AC and DF, these corresponding sides, you should get the same value. Then if you divide AB and DF, you should get the same value. Then you can say that these two triangles are similar triangle. Understand, children? These are the three concepts we came to know. This is very important to prove this theorem. One more concept is there, that is congruence. Congruency of triangle. What is this congruence? There are various postulates that proves congruence of a triangle. That is yes postulate, yes postulate, A postulate, and then yes. These are the four postulates that proves the two triangles are congruous. There is a lot of difference between similarity of the triangle and the congruency of the triangle. Similarity of the triangle means they are not exactly equal, but they have same shape. Okay? But congruency means they are exactly equal. All the sides are equal, all the angles are equal, its area is also equal. Therefore, they are called congruent. Congruent means exactly equal. So these are the postulates that proves yes. If all the three sides of one triangle is equals to three sides of other triangle, then the two triangles can be called as the congruent triangle. No need to prove all the sides, all the angles. Just prove that three sides of one triangle is equals to three sides of another triangle. Then you can say that they are congruent. All the angles also equal. Or SAS postulate. If two sides and angle, if two sides and angle equals to two sides and angle of other triangle, then can be called as congruent triangle. That is SAS postulate. Like this, ASA, AAS, four postulates are there. These four postulates prove the congruency of triangle. If you know this, then AAA criterion of similarity of two triangles theorem we will take, and very easily we can prove. These are the requirements. Very important. If you know this, then you will understand what is this theorem, how to prove this theorem. Everything you will understand only if you know. What are the things you should know? Corresponding angles, meaning of corresponding angles, meaning of corresponding sides. What are similar triangles? Similar triangles must be equiangular, okay, and their sides should be proportional. Their sides should be proportional, okay, and then congruency of triangle. These are the four requirements to prove this triangle, to prove this theorem. Understand, children? Now we will enter into the theorem, how to prove it. Having learned the basic required, now we will prove AAA criterion of similarity of two triangles. Just to recall the statement which says that in two triangles, if in two triangles, which are the two triangles here? ABC and DEF are the two triangles. If in two triangles, corresponding angles are equal. Corresponding angles are equal. Data says that if in two triangles, which are the two triangles? ABC and triangle DEF are the two triangles. Corresponding angles are equal. Corresponding angles. Angle A is equals to angle D. Angle A and angle D are corresponding angles. Angle B of triangle ABC is equals to angle E of triangle DEF. Angle C is equals to angle C of ABC is equals to angle F of DF are equal. This is the first part of the statement, which says if in two triangles ABC and DEF, corresponding angles are equal. This is the condition. Corresponding angles are equal. Then what we need to prove is corresponding sides. Then corresponding sides are in the same ratio. We need to prove that. To prove corresponding sides. You know already what is corresponding angles, corresponding sides, everything. Corresponding sides are the same ratio. AB and DE are the corresponding sides because these are the sides AB and DE opposite to equal angle. Opposite to equal angle. For example, you can see that AB and DE are opposite to C and F, which are equal. Therefore, they are called corresponding sides. And the ratio of corresponding sides is AB by DE. Ratios are equal, is equals to AC by DEF, and that is equals to BC by EF. This is what we have to prove. If in two triangles, if corresponding angles are equal, then the corresponding sides are in the same ratio. The corresponding sides are in the same ratio. Meaning AB by DE is equals to AC by DF is equals to BC by EF. And thereby, and hence, we have to prove that once we prove that their corresponding sides are in the same ratio, then triangle ABC is similar to triangle DEF. Once you prove that their corresponding sides are in the same ratio, then automatically triangle ABC is similar to triangle DEF. How? Because for the two triangles to be similar, these are the two conditions. There should be, two triangles should be equiangular. Two triangles should be equiangular means their corresponding angles should be equal. That condition is there already. And after using this, if we prove their corresponding sides are in the same ratio, then we have proved that they two, that means triangle ABC and DEF, are the similar triangle. Okay, children. Now we'll have to do some constructions. Thereby, very easily we can prove this theorem. Let's do some construction. Mark P. All the constructions will be written in dotted line. Mark P on DE such that DP is equals to AB. DP is equals to AB. And mark Q on DF such that DQ is equals to AC. This construction we have to make, and then join P and Q. Construction. Mark P on DE, mark P on DE such that DP is equals to AB. DP is equals to AB. And also mark Q on DF such that DQ is equals to AC. This is the construction. We have made a small triangle DPQ whose one side DP is equals to AB and DQ is equals to AC. Now we have to prove that triangle ABC is congruent to triangle DPQ. Can you see triangle here? DPQ. This is the constructed triangle by marking P on DE and Q on DF and joining PQ. Join PQ. Join PQ. After this, consider these two triangles ABC and DPQ in triangle. Now we will see the proof of this. In triangle ABC and triangle DPQ. Consider this triangle ABC and DPQ. In triangle ABC and DPQ, by statement, DP is equals to AB or AB is equals to DP. DP is equals to AB or AB is equals to DP. How? By construction. What is the reason? On what reason DP becomes equals to AB or AB becomes equals to DP? By construction, we have constructed in such a way. We have taken a point on DE such that DP should become equals to AB in that way. Now, DQ is also equals to AC. DQ is equals to AC. How? By construction. By construction. And you can see that angle D is equals to angle A. Angle D is equals to angle A. How? By data. By the statement. What does the statement say? The two triangles are equiangular. You can see that this D belongs to DEF triangle and D angle D is equals to angle A, which you have taken here. Angle D is equals to angle A or angle A is equals to angle D. This is by data. Angle D is equals to angle A because this D belongs to DEF triangle as well as DPQ triangle. Understand? Angle D is equals to angle A. Now see that in any triangles, in any two triangles, if two sides and including angle, two sides and including angle of one triangle is equals to two sides and including angle of other triangle, then by SAS postulate, triangle ABC is congruent to triangle DPQ. Triangle ABC is congruent. Triangle ABC is congruent to DPQ. How? By SAS postulate. What does it say? SAS postulate. If two sides and including angle of one triangle is equals to two sides and including angle of other triangle, then two triangles should be considered as congruent. Congruent means they are exactly equal. All the sides of one triangle is equals to all the sides of other triangle, and all the angles of one triangle is equals to all the angles of other triangle, and their area also equal. Congruent means they are exactly same, one and the same. Thus, now we came to know triangle ABC is exactly equal to DPQ, that is they are congruent. Therefore, by common part of the congruent triangle, we can take angle P is equals to angle B, or angle B is equals to angle P, and angle Q of the triangle DPQ is equals to angle C. How? By CP, CT, common part of the congruent triangle. By this we came to know that angle P is equals to angle B and angle Q is equals to angle C, or angle B of triangle ABC is equals to angle P, or angle C of ABC is equals to angle Q of DPQ. You can write in this way, or you can also write angle B is equals to angle B is equals to angle P, and angle C is equals to angle Q. You can write this. How? What made it to take angle B is equals to angle P and angle C is equals to angle Q? Because these two triangles are congruent. How? By SAS postulate. Two sides and including angle of ABC is equals to two sides and including angle of DPQ. Therefore, they are congruent. Congruent means they are exactly equal. Okay, children. Now, once you prove they are congruent, then you can take angle B is equals to angle P and angle C is equals to angle Q. Now, you enter into data what is given. See the data properly. Angle B and angle C. Angle B and angle C are equals to angle E and angle F. By data, what is given here by data? Angle B is equals to angle E. But angle B is also equals to angle P by congruency of these two triangles. Angle B is equals to angle P. Since angle B is equals to both angle E of DEF triangle and angle P of DPQ triangle, angle E is equals to angle P. Angle E is equals to angle P. Understand? Now, see that this C, this angle C of ABC triangle is equals to angle F of DEF as well as angle Q of DPQ triangle. Angle C is equals to angle F by the data and also equals to angle Q by congruency of these two triangles. Therefore, angle F is equals to angle Q. Similarly in this way. Now we came to know angle E is equals to angle P and angle F is equals to angle Q. Angle E is equals to angle P, angle F is equals to angle Q. See that. Angle E is equals to angle P or angle P is equals to angle E and angle Q is equals to angle F or angle F is equals to angle Q. What does it mean? These are the two lines. And DE or EP is a transversal line. If a transversal line crosses across these two lines and this angle become corresponding angles. Angle P and angle E are corresponding. If corresponding angles are equal, then these two PQ and EF must be parallel lines. If the corresponding angles, if a transversal cuts two lines and the corresponding angles becomes equal, then the two lines PQ and EF are parallel lines. Since angle P corresponding angle is equals to angle E corresponding angle, they are equal, therefore we consider PQ, line PQ and EF are parallel lines. How you came to know angle PQ and angle EF are parallel lines? Because corresponding angles angle E is equals to angle P. We have proved that. So these two are equal and thus we say that PQ is parallel to EF. This is one required. All these things we did to prove this itself. PQ is parallel to EF. How you proved? Very, very important. This is the first step in proving this AAA criterion of similarity of two triangles. If you prove this itself, then we can apply, recall what we learnt, BPT theorem. What does it say? A line drawn parallel to one of the sides of the triangle to intersect other two sides at a distinct point, then other two sides are divided in an equal ratio. So recall that, based on that we are going to prove this AAA criterion of similarity of two triangles. Now we prove that PQ is equals to EF. PQ is equals to EF. Sorry, PQ is parallel to EF. PQ is parallel to EF. Since PQ is parallel to EF, according to BPT, this line PQ divides other two sides in the equal ratio, that is DP by PE is equals to DQ by QF by BPT. Therefore, BP by PE is equals to DQ by QF. You got this point? So we proved PQ is parallel to EF. Once we proved PQ is parallel to EF in this DEF triangle, then we can apply BPT, basic proportionality theorem. Based on the basic proportionality theorem, now this PQ line divides other two sides. Which are the other two sides? DE and DF in an equal ratio, that is DP by PE is equals to DQ by F. Just reciprocate this. Reciprocate. Just reciprocate. If you reciprocate, same becomes PE by DQ. Reciprocating is equals to QF and DQ. Numerator made as a denominator, denominator made as a numerator. Reciprocating. Now add 1 on the both sides to get the corollary of BPT. Add 1 on the both sides. Add plus 1 on both sides. So that PE by DP plus 1, adding 1 on the both sides. If you add on the both sides, add or subtract both the sides, you are not changing anything. Then after taking the LCM, you will get PE plus DP by DP is equals to QF plus DQ by DQ. You will get this. If you add PE by DP with plus 1, you have to take LCM. After taking LCM, you get PE plus DP by DP is equals to QF plus DQ divided by DQ. Observe now. PE plus DP. Come to the triangle. PE plus DP. PE plus DP is nothing but DE. PE, this part plus this part is equals to DE, the full part, that is DE. Now I'll take here DE. This PE plus DP is DE divided by DP, keep as it is. Now observe. QF, this part, and DQ. QF plus DQ is nothing but whole DF. Therefore, in place of QF plus DQ, I am writing DF by DQ, right, as it is, DQ. Understand children how it came? Now, come back to the construction. What construction we made? We made construction DP is equals to DQ. We have marked P on this triangle DEF such that DP is equals to AB itself. DP is equals to AB. Therefore, in place of DP, we can write AB. DE by AB. Why DE by AB? Because DP is nothing but AB. And again, DF. What is the DQ? DQ is nothing but AC. DQ is nothing but AC. Again, reciprocate so that we will get AB by DE is equals to AC by DF. AB by, after reciprocating, AB by DE is equals to AC by DF. Now see that what we have got, AB by DE, AB by DE is equals to AC by DF. AB and DE are the corresponding sides, and if taken in a ratio, that is becoming equal to AC and DF. In the same way, similar way, if you do in the similar way, similarly, AB by DE also becomes equals to AB by DE also becomes equals to BC by EF. BC by EF. In the same way, if you do, if you change the parallel, PQ if you write along DEF and EF, then you will get the same way you can prove. How you put AB by D is equal to AC by F. The same way, AB by DE is equals to BC by EF also you can prove the similar way. Just write similarly AB by DE is equals to BC by EF. Similarly, thus you see that AB by DE is equals to AC by DF is equals to, this AB is also equals to BC by EF. And this is what we want to prove. What is this meaning? The meaning is what we need to prove. That is, the corresponding sides are in the same ratio. Which are the corresponding sides? AB and DE are the corresponding sides. They are in the same ratio. All the corresponding sides. Take AB by DE, which becomes equals to AC by DF, and which becomes equals to BC by EF. Corresponding sides are in the same ratio. Meaning of this is corresponding sides in the same ratio. You will come to know this once you solve the problems, questions based on this particular theorem. You will clearly understand this. Understand, children? Now, what was the given? This was the given. In the two triangle, ABC and DEF, corresponding angles are equal. They said the corresponding angles are equal. So, and what we want to prove? We want to prove that the corresponding sides are in the same ratio. We have proved corresponding sides are in the same ratio. Once we prove the corresponding sides are in the same ratio, it is as though we have proved triangle ABC is similar to triangle DEF. This also is proved. Why? Because the condition for the two triangles to be similar is they should be equiangular. Their corresponding angles should be equal and the corresponding sides should be in the same ratio. Corresponding angles are equal by theta, and we have proved that corresponding sides are in the same ratio. Since the two conditions are satisfied, so we can say that triangle ABC is similar to triangle DEF. These three equiangular corresponding angles in two triangle, corresponding angles are equal. Then automatically, if while solving problem, if corresponding angles are equal, or if two triangles are equiangular, then their corresponding sides are automatically divided in the same ratio, are in the same ratio. Okay, and if their corresponding sides are the same ratio, then they are automatically what? Similar triangles. So they three are correlated. If in a question it is given, two triangles are similar. If two triangles are similar, then what you have choice? You have that you can easily derive that their corresponding angles are equal and the corresponding sides are the same ratio. These two automatically comes when you say the two triangles are similar triangles. If the corresponding sides are the same ratio, then automatically what should come in your mind? If corresponding sides are the same ratio, then they must be equiangular triangle. If they are equiangular triangle, then two triangles are similar. Two triangles are similar is equals to they are equiangular is equals to their corresponding sides divided in the same ratio, or their corresponding sides are in the same ratio. These three are equal. These three words, once you take similar triangle, then they are equiangular as well as their sides are in the same ratio. Did you understand, children? If you have any doubt, don't worry, post your doubts. We'll clarify that in the next video. Bye bye, children.